Before we can carry out equilibrium or large angle stability analysis, we need to have a series of load cases defined. Hydromax has an integrated load case editor, and that allows us to enter a list of masses and their respective centres of gravity. It's also possible to group together commonly used sets of masses into load groups. So one common example would be the lightship condition with all of the standard loads that are permanently fixed to the vessel. Tanks which have been defined in Hydromax are automatically included in the load case, and all we have to do is enter the percentage full in order to define what the total mass is, and we'll also demonstrate in a moment how to deal with the free surface effect of any fluids in tanks. The load case can have entries inserted to automatically tabulate totals and subtotals, and I'll also show you some display options for color coding loads and displaying load case masses. Also, finally, a handy hint: if you want to apply a pure moment to your load case, then you cannot have a negative mass, but it is possible to have a negative quantity. So if you add two items, one of which has a quantity of 1 and one of which has a quantity of -1, then by setting up your mass and lever appropriately, you can define a pure healing or trimming moment. Let's switch over to Hydromax and take a look at our load case window. I'm in the load case window now, and you can see that we have a number of tabs along the bottom for each of the load cases. We can create new load cases from the File menu. The first load case I'm looking at is actually a load group. If I edit the load case, we'll see that the load group option is ticked. That means it's a list of loads that can then be used in the other load cases. So we have here some mass items for the hull itself, the superstructure, pieces of large fixed equipment, and so forth. If we move across to the next tab, another load case, what we can see is that our previous load ship, which was named load group, which was named Lightship LC, is now included by name in this load schedule, and so its mass is automatically included. We can see here we have a list of subsequent masses here, and we have a column here which is labeled total variable loads. Any entry in this list which starts with the word total or subtotal will automatically tabulate the items immediately above it. We can insert any number of empty rows in there just to separate the items and make the table look a little bit better. You can use the commands in the edit menu to add and delete loads, move items up and down, add surface areas, and also sort items in the list. You can also see in this load case that the tanks defined in this model have automatically been inserted into this load case. This is the departure load case, and so their percentage fulls are shown here between 80 and 100% full. If I want to change the amount of fluid in those tanks, I just need to change the percentage full, and the other items will be updated automatically. If I switch over to the arrival load case, we'll see the same tanks are automatically entered, but different percentage fulls have been entered by the user. In the case of tanks, we should also be aware that there's potential free surface correction. So let's scroll across in this table, and we'll see the last two columns are total free surface moment and the type of free surface moment for this particular tank. If we look at the drop downs in this list here, we can see we have 4 different ways of defining the free surface moment. The maximum uses the maximum free surface moment at any sounding through the depth of the tank. So it's a worst case scenario for any level of fluid. The actual setting allows us to use the free surface moment calculated from the actual percentage full in this particular load case. The IMO setting computes the free surface moment using a technique defined by the IMO. It's based on a rectangular box that's 50% full. And finally, you can also define your own user-specified free surface moment, where just the value that you enter will be used to correct the free surface. When you put in or that will compute those free surface moments, they'll be added to the free surface correction, which is then added to the adjusted VCG of the design. When we're viewing in these tables, in the View menu, there's a color option so that we can use color coding to color code the masses, and also color code the tanks by fluid. So each fluid gets a different color. Each tank at least gets a different color based on its fluid. And if we go to a graphical view, we have an option here to turn on the display of load case masses, so that as we move between different load cases, we can see which loads are where in that particular load case. That's a brief introduction to load cases. Thank you for watching.